Hey guys, Miss Peterson here, and today we're going to be looking at gas properties. We're going to be using a pHet simulation to graph the relationships between volume, temperature, and pressure, depending on which data set you want to look at. So this is part 3 of our gas properties simulation, the quantitative data. So if you need help on that in the graph, here's what we're going to do. Okay, so first, we need to pick which data set we're going to analyze. So what our independent variable is and what our dependent variable is. I'm going to go ahead and just do this first row right here on the table. So looking at the relationship between pressure and volume, holding the temperature constant, my independent variable, so the one I'm changing is going to be volume, and my dependent variable is going to be pressure. Okay, so let me go ahead and put those in. Our independent variable is volume. Now, in the simulation, unfortunately, we can't measure volume directly. So instead, we're just going to be using the width of the container to be our representation of volume. Since the height and the depth of the box are in theory staying the same, we can just use the width for that. So that will be in units of nanometers. Okay. And our dependent variable is going to be P, the pressure. So pressure. And that in the simulation is in units of atmospheres. So ATM. Okay. So let's go ahead and get a sample of gas and get going. Okay. So I'm going to add 200 heavy particles and let them stabilize. Once they're stabilized, I'm going to go ahead and tell the system to hold temperature constant. So my temperature is being held constant at 300 K. I'm just going to note that on the bottom just so I have it referenced. Okay. So then I'm going to change my independent variable, the volume, and see how that affects the pressure. So I'm going to go ahead and do my first data point with the volume pretty small. So with the volume at 5 nanometers, we're at, okay, it's going back and forth between 46.5 to 46.7. So I'll go ahead and say around 46.8. Okay, so that'll be 5 and 46.8. Now, something important to remember is when we are doing and using Google Sheets, okay, Google Sheets does not understand letters. So you only want to include the units in your heading, not in your actual cell. You just want numbers in there. Okay, so now let's go ahead. I'm just going to split my screen here so that we can get the rest of the data. Pull it out a little more. Now it's at 6.3. And my pressure right here is at, okay, looks like it's still going up a bit. Okay, now it's staying right around 37, up to 37.7, back down. I'm going to go ahead and estimate around 37.5. And then I'll make my volume a little bigger. Now it's at 7.9. And my pressure is at about 29.6. So I can see that relationship. As the volume is increasing, the pressure is decreasing, which makes sense to me. Okay, if we give the particles more room to move, they're going to run into the walls less. Okay, so then I'm at 10.7 and 21.7. And I'll get one more data point here. 12.1, and my pressure's at about 19.0. Okay, so there's our data. Now there are other data sets you could get. Okay, you could have held the volume constant and seen how changing the temperature affects the pressure. Okay, so that is another set you could have done. And then the other one you could have done is the pressure with the changing volume. So that one holds the pressure constant, and we can see how we can change the temperature and how that affects the volume. Okay, that's for this data set 3 here. Okay, or that one where you change the volume and you keep that temperature constant. Okay. Okay, cool. So now let's go ahead and graph it. So in order to graph in Google Sheets, the first thing you need to do is select what you want to graph. Okay, just select your header units and your data tables. Okay, or just select the numbers when in doubt. Okay, then we're going to go to Insert Chart. And I don't want a column chart. I want a scatter plot. Now, sometimes it'll do this by default, and it'll know that I want the A column on my x-axis and the Y column on my y-axis. So this is your X and your Y, but it didn't do that for me here. So if it doesn't, we need to be in Setup, and I'm going to add the x-axis. I want my x-axis to be my dependent variable, the volume. And I want pressure to be on my y-axis. So I don't need volume there. Okay, there we got it. I'm going to go over to Customize to add my axis titles. Okay, I'm going to add at 300K that constant to the top of my graph. And then I'm going to add the horizontal axis title, which is the volume in nanometers, and the vertical axis title, which is the pressure in atmospheres. Okay, and we can see that sort of inverse relationship. Let's see, we could even put not an exponential. Nah, none of those trend lines are probably going to work for this one. It is an inverse relationship. So I'm just going to go ahead and leave it right at that. And that's my graph. Okay. Now, on the second tab of this Excel sheet, we have our simulation data, and then we have our calculation. This is a spreadsheet that will give you the predict the pressure for a changing situation. So we set our temperature at 300K. So if I put my temperature in as 300 in both scenarios, I'm going to look and see if this computational model can predict my data. So in the first row of my data table, my volume was 5 and my pressure was 46.8. So my volume was 5 and my pressure was 46.8. Okay. Now let's go ahead and see what it predicts for volume 2, what it would predict for that pressure. When I changed the volume to 6.3. Will it be 37.5-ish? Let's find out. Volume 2 was at 6.3, and what do you know? We get 37. Okay, so this computational model will allow us to predict what the pressure would be if we know the temperature and volume of our sample. Okay, cool. Okay, cool.